Hey guys, it's my second FPGA circuit. Check it out. It's a little LED bouncer. You can use the button on the board to change the speed of the LED, and it just bounces from side to side. So this is on my quest to learn VHDL and hardware design. There's a small problem with it, that I'm not actually debouncing the button. So what that means is sometimes when I press the button, you'll notice that it will skip a value. There it goes. So it's a little bit unreliable like that, and I'll fix it up eventually, I think. So I also added a reset button, so you can press that and resets the position of the LEDs. So how I decided to structure this circuit, I broke it up into a few VHDL files. So there's actually 4, and I'll just quickly follow along on this diagram so you can see how it works. If I start on the output side, we have this circuit here, the LED bouncer, this one, and what it does is it takes a clock in and a reset and outputs the LEDs. So for every tick of the clock, every edge, it advances the LED position, and if the LED hits the edge of the board, it changes the direction of the LED's movement. Now down here we have a 7-segment driver, and this takes in the current speed as a 2-bit value and outputs what's needed to go to the 7-segment display to show the number. So it'll output 0, 1, 2 or 3. Now if you follow those inputs along, you'll notice that this digit here that goes into the 7-segment driver actually comes from this part of the circuit here, which is I've called a clock selector. So all this is a counter that increments every time you press the button. So we take our global clock as input, and we take a button press as input as well. And the counter is a 2-bit counter, and it outputs this speed out value. Now, as well as going to the 7-segment display, the speed out value goes here to this final part of the circuit, which is the clock divider. So this takes the main board clock and a 2-bit value to select the speed that you want, and then it outputs the slower clock, which drives the LEDs. So yeah, that's it.